Well, let's look at lesson 1.3 today. And 1.3 is going to be about exponents, roots and order of operations. So, to get us started, a little bit of work on exponents. And you're looking at the screen I have. It's also on your notes, so grab those. And let's just walk through these real quickly. See which ones you can do by memory. Maybe hit pause and go through it. So I know 4 squared is 16. 15 squared is 225. 7 squared is 49. 12 squared, 144. 9 squared, 9 times 9, 81. 5 times 5, 25. 3 squared, 9. 13 squared, 169. 2 squared, 2 times 2, we all know that one, 4. 14 squared is 196. I always kind of keep 13 squared and 14 squared, just the reversal of the digits, easy to remember. 36 and 16 squared, 256. So just, getting them back into your brain, we will use those a lot throughout the year. So like I said, we're working on section 1.3. Here are the topics that we're going to go through. So let's get started. Section 1.3 does a lot with order of operations. And while I know you've done order of operations multiple years, it still is a topic that people struggle with, getting that order right. So they've got them laid out here in our textbook. It says work separately above and below a fraction bar. So if we have a fraction present, look above it, work the stuff above, work the stuff independently below, and then go forward with it. Grouping symbols such as parentheses, brackets, absolute values, all of those work as grouping symbols. And in a sense, a fraction bar works as a grouping symbol because we group the stuff on top separate from the grouping this stuff below. Evaluate your powers, your roots, your absolute values next, then multiplication. Finally, at the end, we bring it all together with addition and subtraction if they were present. We know this as PEMDAS, or the please excuse my dear Aunt Sally idea, where P stood for parentheses, but more importantly, P acts as a grouping symbol. The parentheses, the brackets, the absolute values, the fraction bars, all of those work as grouping symbols. On with the show. Example 1, using exponents. So I know this means really repeated multiplication, so I can take -10 times -10 times -10. The first -10 times -10 gives me positive 100. And then I come back with multiplying by another -10. Well, now my answer is going to be negative 100 times 10 will add an extra 0, so I get up to 1,000. -3 repeated 4 times, so I'd end up with this. And I can tell that I'm going to have an even number of negative symbols multiplied. That's going to give me a positive, isn't it? Or I could even say I'm going to group these, multiply them first, multiply those two first or next, and 9 times 9 gives me positive 81. What about fractions? How do we multiply fractions? Well, I'm going to take 2 sevenths times 2 sevenths times 2 sevenths. And you can do 2 at a time, like you could group 2 of these and say, okay, I'm coming out with 4 over 49. And now I'm going to swing in that other 2 sevenths and multiply by that. So on top, I'm going to get 4 times 2 is 8, and 7 times 49. I'm just looking for the answer because that one I don't have in my head. 343. Oh, that's right. It's been summer break, right? 7 cubed is 343. We'll see that one quite a bit this year too. It's just been a few months. Objective 2. It says write the positive or principal square root. Oops, see, what did I do? Write the positive or principal square root of a number with the symbol square root, which is called a radical sign. So often you'll hear people refer to this as negative radical 49. When they say that, most likely they're referring to the square root. But it's probably more clear if we said the square root of 49, because eventually we're going to get into cube roots, fourth roots, fifth roots. Okay? Well, with A, we've got a fraction, and by the rules, we can split up those square roots. So I'm going to make it easy on myself and deal with the top one. The square root of 121 is 11, and the square root of 81 is 9. So it gets an answer of negative 11 ninths. B, well, we all should know that one. Square root of 49 is 7. I do not need to put plus or minus. You're probably like thinking, oh, what about that plus minus from previous math courses? Well, in this case, I'm seeing the radical symbol or square root symbol. I am not seeing a plus or minus in front of it. So I am solely dealing with the positive square root. It's the understood positive square root, and that's kind of what this was talking about, the principal square root. On D, I want to take the square root of negative 49. Well, the reason B worked, let's just talk about why did that work. Well, 49 is the same thing as 7 squared. And taking the square root of something squared leaves us with the object being squared. So I'm kind of undoing the square. Square root's inverse of squaring, so it undoes it. When I get to D, can I write negative 49 as a perfect square, like negative 7 squared? No, I cannot, because that would say I've got the square root of positive 49, right? If I square the negative. So this one actually does not have an answer. So I would just say this is undefined for us. Some of you that had it last year in Algebra 2 may remember we talk about imaginaries, and imaginaries are what are necessary to do this particular problem. We will get into imaginaries. Yeah, I think it's section 8 or unit 8. All right, objective 3, using the order of operation. This is our PEMDAS coming into effect. So it says simplify. And I just got to remember, I got to work parentheses, then I'll work my exponents. PEM, multiplication and division, done from left to right. It doesn't mean multiplication comes first, just that these have the same level of hierarchy, done left to right, and the same is true with addition and subtraction. I could say subtraction and addition. It still is a left to right order of operations there. So I'm scanning through A, and I see multiplication, and I see more multiplication. Well, multiplication comes before addition and subtraction, so I'm going to hold off on that addition function. So let's multiply. So I get a 45 and an 8. Bring down that addition, and now 45 plus 8 is 53. Let's look at B. So take a quick scan. What am I doing? Well, my eyes are traveling left to right, and I'm just getting a quick read on what it's asking me to do. And my quick read says you've got division going on, you have multiplication going on, and you have subtraction. Well, PEMDAS would say multiplication and division are preceding any work subtraction-wise. So I'm going to do multiplication and division from my left to right sequence. So hold off on subtraction. Let's get this division done. That would create 2, and then I've got to multiply by, that makes 3. 12 divided by 4 makes 3. Multiply it by 2. So multiplication now takes precedence. 6 times 2 is 3 times 2 is 6. Whoa, having some struggles there. 4 minus 6 is negative 2. You just really need to decide what comes first. Okay, did you get a quick look at C? My quick look drew my eyes immediately to that. I saw an exponent. I also saw these parentheses, but I think my brain was so quick in ruling them out that my exponent's going to come first, because these parentheses really aren't doing a whole lot for me. This just says I have to add, but there's no multiplication going on out front or anything like that. So honestly, This particular parenthesis was not even necessary. And the other one's a little bit more uncertain whether I need it or not, so I'm going to leave it in place. But I still am going to proceed with this being my first step. So I'm going to go 4 plus 2 minus 3 squared is 9 minus 8 minus 3. Okay, let's do 6 minus 9 minus, get that parentheses done, is 5. And now I'm just going to sweep left to right and evaluate these two subtractions. So 6 minus 9 is negative 3 minus 5 gets me to negative 8. You see me writing down a lot of steps, and I do that because then my brain doesn't have to keep track of so much work in my head, and it just helps me get the correct answer the first go round. Try it, you'll like it. All right, D. Lots going on here. The biggest thing that my brain sorted out, and I hope yours did too, was there was a fraction bar. And fraction bars act as grouping symbols. So indeed, what we are going to do is kind of work the top segment and the bottom denominator separately, and then the final step will be bringing it together. All right, so D. Up on top, let's go to the blue ink. Scanning left to right. Well, the square root of 9 becomes 3, so I might as well rewrite that number. And then I'm down to multiplication, subtraction, addition. Well, multiplication comes first. So a half times 10 is 5 minus 6 plus 3. I'm going to group and do the bottom, get a little work done on the bottom. Once again, I see an exponent. So that's going to be a 4 there. So I'll have 3 times 4. So I have multiplication, subtraction, multiplication again. Well, multiplication takes precedent over subtraction. So let's multiply. 5/6 of 12. Well, that's going to be a fairly high number, isn't it? Because it's almost like taking 1 times 12. So 5/6. Well, 6 goes into 12 2 times. 5 times 2 becomes 10. I told you it was going to be close to 12. Minus 3 times 4. 3 times 4, let's write down 12. Okay, continuing on with this separation of still working top, separately working bottom, till we get to a final number. All right, now we're into subtraction and addition. So I'm going to take 5 minus 6 is negative 1. Negative 1 plus 3. I know you could probably, well, let's even do it. We get 2. All right, on the bottom, even more simplified, 10 minus 12 is negative 2. Bring that over here. Final answer, I'm getting negative 1. All right? That was a tricky one. That'll take you a moment to do on it. Number 4. This is our last example. It says evaluate algebraic expressions for given values of the variables. So, by the way they say algebraic expressions, I haven't looked below, but I know in algebra we get into a thing called variables. And I suspect we'll hit those. So let's look at A. Evaluate the expression. Expression just means in math that there's going to be no equal sign present. It's not an equation like W plus 5 equals 7. That's an equation. It has an equal sign. An expression would be something that just simply states W plus 5. It's kind of like an incomplete sentence. All right, evaluate the expression. W equals 4. Oh, hey, they used a W. Didn't even know. X equals negative 12. Y equals 64. Z equals negative 3. And then here is the algebraic expression we're trying to do. It's really just a lot of substitution. So we're going to substitute values in, and we're going to do it very carefully. Substitution. So X is negative 12. This will turn into 5 times negative 12 plus Z is negative 3. Square root of Y is 64. Yay, perfect square there. That'll be nice. W is 4 minus 1. So once you're pretty certain that you copied just fine and substituted just fine, um, let's go forward. What would you do first? Well, in my thinking, I'm going to exchange square root of 64 for 8 because that was a kind of like an exponent. It's a power thing. And that comes before multiplication and division. Is there any multiplication? Yes. I see two steps of multiplication. I see a step of multiplication there and a step of multiplication there, joined with addition. So I'll hold off on the addition. The multiplication gets me a negative 60. The other multiplication would be negative 3 times 8 gets me a negative 24. I'm just going to use parentheses to help isolate that negative so I've got the plus minus going on. On the bottom, fractions, we do groupings, numerator and denominator separately, so it's a 3. Next step is kind of finishing here. Negative 60 and a negative 24 make negative 84 divided by 3. And I wonder if it goes in perfectly. Well, we could do a quick little long division, couldn't we? 3 goes into 8. 2 times 3 is 6. Subtract them, we get 24. There we go. There's our answer. Negative 28. Remember, still in chapter 1, we will be operating without calculators, so get familiar with doing long division. Here is the homework. Homework you will find on page 28 of your textbook. We are doing evens in this problem set, and I did show the first ones. Go ahead and use a calculator because some of these numbers, especially when you get into 6 raised to the 4th, I don't want to multiply that. I know you don't want to multiply 6 4 times. This one would be really not much fun. So go ahead, use calculator, answer in fraction form on those two fractions. I don't want to see a decimal answer. So for instance, this is going to become 1 over 6 to the 4th, and then 1 over expand 6 to the 4th and give me its number, and leave your answer as 1 over whatever that is. And hopefully the rest of these kind of look like what we just did in our notes. I think you'll find that true this year, that we've done a very good job of linking the notes with our homework. So you should be able to handle all of these problems. Show it on a separate sheet of paper if you don't have room to do your work on this page, if you've printed it out. All right, have a great day.